Absolute value functions. Objective. By this lesson, you should be able to graph absolute value functions. Given a function of f of x, graph the function absolute value of f of x. These are slightly different things. So first, what is an absolute value function? The absolute value or modulus of a real number, x, is its distance from 0 on the number line. So keep in mind, the distance. That's why absolute value is always positive, because distance is always positive. So for example, if I give you 7, absolute value of 7, it's saying, hey, how far is 7 from 0? Well, it's 7 away. So it's a positive 7. And likewise, if I give you absolute value negative 5, it's saying, hey, how far is negative 5 from 0? Well, it's 5 away. So absolute value is always positive. Absolute value function, y equals the relation of y equals absolute value of x, it's called the absolute value function, and looks like this. You might ask, why does it look like a v for? Well, if you look at the graph of y equals x, right? The graph of y equals x looks like this. Well, like this. Slope of 1. But then we look at the absolute value of that. Well, you can't be negative. So this portion right here gets moved up and becomes positive. So it gets flipped up here, and you get this guy. An absolute value graph of v. Another way to think about it as a piecewise function, it's positive x when it's greater than 0, and it's negative x when it's less than 0. And either way, you get a positive number. It's like that. So let's graph a couple of these. Let's graph y equals absolute value of x minus 2 plus 3. So the way I start off graphing these is I find the starting point, which in this case will be inside opposite, outside follow if we graph everything. So 2 and 3. So we're going to start at 2 on my x and 3 on my y. And then we know it's a v because we're just doing a sketch. So it looks like this. And technically this here, my slope should be 1. So you should be going up 1 over 1, up 1 over 1, up 1 over 1. So it's a line. So it has a slope like a normal slope. And when we keep that in mind, we do this one. Right? So we're going to start at inside opposite, outside follow. So negative 4 and 1. So right here. And in this case, it's a negative 2. That's like my slope. Because again, it's just a line. So we're going to go down 2 over 1. So we're going to choose slope like a normal slope. Down 2 over 1. So we're going to go from here. We're going to go down 2, 1, 2, and over 1. So the point right there. And then, unlike a normal slope, we're not going to go this way also. We're just going to go same thing on the opposite. Because it is a V. So down 2 and left 1. And we get a little graph looks like this. Opening down because it's negative. So that's our graph of absolute value function. Now, what if I give you a graph of absolute value of f? So if I give you a graph and I want to graph the absolute value of it, keep in mind what it does. Absolute value makes things positive because it's a distance. So all we're going to do is wherever it's negative, we're going to flip it to be positive. So if we look at the one right here, right, this part stays the same. That's not going to change. But this part down here that's negative, well, it's going to flip up. It's going to cross that. Instead of crossing that negative 2, we're going to cross that 2. It's going to look like this. So there we go. Right, so this part stayed, and then this part we changed. Over here, right, what part stays? This part. That's all the same, but this part gets flipped up. We're going to flip it across here because it has to be positive. So it's going to look like this. So negative 4 becomes 4, the asymptote is, and it's going to look kind of like this. So that's our graph, right, the purple. Going like this, down, and then back up again. On the same set of axes, graph this and this. So let's graph both of these. And that's always one way you could graph an absolute value function. If you don't remember the inside, opposite, outside follow and make a v thing, just okay. Graph of this graph is normally. So let's rewrite in slope intercept form. Negative 3x plus 5. So 1, 2, 3, 4, 5. Go down 3 over 1. We have a graph that kind of looks like this. Now let's graph this guy. That's the value of it. Well, that's the value of it. Keeps all the positive, and then against negative, it flips it up. So it sounds like this. Then from here on, it flips it up. So there's my graph of absolute value of 5 minus 3x. Okay, let's do one more. Draw the graph of 3x times x minus 2 on the same set of axes. Draw the absolute value of that graph. So, like we did parabolas a couple chapters ago. So we're going to graph that. Easiest way to graph this is find the x-intercept. So we're going to set equal to 0. We're going to split it. 3x equals 0, which is just x equals 0. And then x minus 2 equals 0. So x equals 2. So again, we're just doing a sketch. We're not doing a perfect graph. oops, x equals 2. There we go. X, y. So my x-intercepts are 0 and 2. So 0, then 1, 2, 3, 4 right here. Again, this is a sketch. It is a positive x squared. If we multiply it out, we're going to get positive x squared, so it should be opening up. So it's kind of like this. Again, if we're trying to do a better sketch, we can find axis symmetry and all that good stuff, but we're just going to do a sketch. Now let's graph the absolute value. I'll do that in red. Remember, all the positive stays. So this is going to stay, and that's going to stay. This negative part gets flipped up. So it's going to look like this. Oops. So kind of like that. That's the lesson.